You can make some really cool stuff on the Desmos graphing calculator. Function art, games, art programs, all with math and formulas. But last year, I got an idea. That should be easy. I could totally do that. So, how do you even start something like this? Well, Desmos lets you upload images. You can squash and stretch the image as you please, as well as change the opacity, which is usually great if you want to trace over something, but that can also be used to display information without needing to explicitly graph it. This means that if we need to pack a bunch of Earth data into our graph, images would be the perfect way to... I said, images would be the perfect way to... Crap. Images are stored natively in the graph. Desmos' storage limit is 5 megabytes. Google Earth is a little bigger than that. Let's start somewhere else then. How do we even visualize this data? Well, the Earth exists in 3 dimensions, which means we could maybe use our alternative, Desmos' younger sibling, Desmos 3D. Because the 3D world is complicated, Desmos 3D doesn't have direct image upload, which means we have to translate these over ourselves. How do we do this? Well, each image can be visualized as lists of individual pixels, with each pixel having a certain color containing a hue, saturation, and value. We could use a color map on the 3D calculator to not only translate images, but also map them onto different surfaces. This solution would allow us to... Turns out that color maps don't support lists, so back to the drawing board. Let's start somewhere else. Again. We can go back to 2D, so at least we have access to images, but how would we keep the 3-dimensional effect? Thankfully, we can employ the strategy generations of coders have used to make things that look much more impressive than they're capable of. Here's Math Enthusiast 314's 3D engine. It's essentially doing what any virtual 3D environment does behind the scenes. It's simulating a 3D space and projecting it onto your 2D screen. Now, we can get both 3 dimensions and images in one graph. At this point, I experimented with a bunch of different ways to display data with this setup. Using different combinations of squashing and stretching an image along with the axes they lie in, you can shear images horizontally and vertically to give the illusion of 3D perspective. Can you stop doing that? Shearing works for one image, but variable axes are global, so it wouldn't work for all the images we need for this project. This is around the time I plateaued. I was lost and I reached the point where I didn't really know what to do anymore, so I went and slacked for a bit. I eat the bug.
Hello, squad.
Hello. Hello.
I didn't think we'd get here, but actually I had faith in you always.
I didn't. Jason died by his own folly.
I fucking knew you would. Visor gave a PowerPoint presentation.
What if we employed the second strategy generations of coders have used to make things that look much more impressive than they're capable of?
Lie!
Instead of having an actual 3D globe, what if we fake it? Hear me out. First, place optimally distanced points on a sphere. I myself opted to use the Fibonacci algorithm due to its ease of implementation. Don't ask me how it works, I don't know either. Then, rotate the sphere such that you're looking directly at one of those points. See those coordinates? What we can potentially do is pre-render the Earth as looked from above those coordinates via screenshot, and attach the image at that point. Now, repeat that process for all the points on the sphere. Whenever the user is rotating the Earth themselves, maybe we can show them that static image of what the Earth would look like if they were looking approximately at that location. Essentially, we can make this graph one big, complicated PowerPoint to fake the illusion of a 3D model of the Earth.
What the fuck are you talking about?
Wait, that's a lot of images. So how are we even going to get this data? For this part, my worst fears came true. I had to
Use external tools!
and
Learn something new!
QGIS, Quantum Geographic Information System, is a free, open-source software that allows users to create.
since Google Earth and a lot of other sources of this imagery are copyrighted, I defined an alternative public source for this data. Thankfully, NASA, my goat, had a bunch of these, so I just downloaded the highest quality map I could find in GQIS's file format. Then, I slapped that onto a sphere and asked GQIS to take 1,000 pictures in a very long and specific set of Fibonacci coordinates, dropping them all in this folder right here. Yep. 20 gigabytes is a lot. It's not 5 petabytes a lot, but it would still take like 4,000 Desmos graphs to store, which is nowhere near feasible for me. However, I have an ace up my sleeve. Imgur! If you upload an image to Imgur and embed it into your Desmos graph, you can use that image without the graph natively storing its data. This compresses the effective size of your image down to a few characters, making it possible to fit the original 1,000 pictures within that 5 megabyte limit. So, with that being said, here's the final process I came up with to port all the images into the graph. First, I converted the file formats of 100 images from the GQIS format to a PNG. After that, I used this mass Imgur uploader to get 100 Imgur links of each image in order. Then, I used Google Docs to format the links into Desmos notation. And finally, one by one, I loaded each image into the graph. This, by far, was the longest and most tedious part of the process, taking me around 2 months or so. Nobody's ever fit this many images into a Desmos graph before, so we're gonna run into a few unique issues. For one, I think I uploaded so many images to Imgur that I got IP banned 70% of the way through, and all my uploads were being blocked. Thankfully, one of my best friends let me upload the rest of the data through her computer. I also commissioned her for all the art in this video, so if you like what you see, go commission her! Now! The absurd amount of data we're loading is also going to have a crazy load time. How am I going to inform users of when all the images are being loaded? Starting up the graph on a white screen isn't really the best first impression, and Desmos doesn't have any features that let you directly test for that. This took me a while to figure out, but the solution to this was also quite stupid. I noticed that Desmos loads the images one by one from the top of the expressions to the bottom, which means that we can place indicator images consisting of parts of the loading bar along our data to show the user how many images have been uploaded. Also, a little off script, the UK government banned Imgur, so if you're in the UK right now, you kind of can't access this graph because I used Imgur to store all the data, so sorry about that. Now that we have our data, we've reached the final stretch. Okay, to be so for real, I kinda hate UI design, but I love interfaces with buttons and doodads and gadgets that move around, so I opted for a more simplistic style that incorporates 2 other features. The buttons were pretty easy to make. Desmos allows you to make polygons that, when clicked, perform an action, like changing a variable. When you click the polygon, the graph slides a point across an ease-in function behind the scenes. The result of this function is added to the x-coordinates of the polygon to slide it back smoothly to reveal the rest of the feature you want to use. So, now you can rotate the Earth and click some buttons. Cool. How about zooming in? While I could do the easier solution of scaling up all the images, that would probably require me going back and changing all those values manually in all 1,000 images. Nope, not doing that. At around this time, Desmos had already released a new feature that I really wanted to use as well. Variable axes. How do we use this to zoom in, you ask? Well, if you have a variable and multiply the scale of your viewport by it, if you decrease that variable, your viewport will decrease in size by that factor, and zoom in on your graph because of it. However, our menus are also part of the graph and not tied to the viewport, so when you zoom in, you also throw the UI way off screen. We don't want that. Using the vanishingly little linear algebra I learned, we can define two basis vectors that shrink along with the viewport. These can be used to go back and define every single point in the UI in terms of a linear combination of these vectors. We do this because now, when the zoom variable changes, everything defined in terms of those scaling basis vectors also changes, keeping the menu static in the perspective of the zoomed-in viewport. You know what else is integral to any Google Earth-like program? A search coordinates function. And how do we do that? LERP. Say you have 2 points, and you want to define a continuous line between them. To do this, we can modify the midpoint formula to find the weighted average of these 2 points. If we add a variable that travels between 0 and 1, attach that to the midpoint formula, and graph it, we get a line, which mathematicians call a linear interpolation and computer scientists call a LERP. If we swap the x and y values of that point with the latitude and longitude variables, we can travel alongside the LERP of our current coordinates and our destination coordinates to find the image closest to our destination. We can't just have the Earth. What about the sun and stars? I didn't really know where to start with this, so I gotta admit, I did the lazy solution. I randomly generated star-colored points and made them travel across the viewport as you rotated the Earth. I'm really happy I did the quick solution though, because it created a really nice effect that helped the atmosphere of the graph and stayed really performant, which is something you really need for Desmos graphs. Last but not least, I needed to make a title screen. For this, we need to learn about intentional errors. As you've seen before, when Desmos notices any error, it stops whatever it's calculating and warns you. If you place any toggleable error, that is, a function that returns an error only when you want it to, in front of anything that requires a lot of computation power, then when that error is toggled, Desmos stops computing all of that thing at once. This essentially gives us full control over what Desmos is focusing on, which is integral to making a title screen that both prioritizes the loading of the data and looks nice in the process. So, when we want the user to start the graph, the intentional error needs to be turned on such that you only see the loading bar and none of the behind-the-scenes work slowly be loaded up. I can't fully stop the user from clicking the start button though. Again, we are on a graphing calculator. But I'll just have to trust that no one gets too curious. After adding some fun facts, polish, and a logo using my Desmos art program, it's done. It is done. So yeah, that's it. That's how I made Desmos Earth. I was actually able to finish all of this in time for Desmos' 2025 Global Art Contest, but was disqualified because of something about bandwidth and 1,000 images not mixing very well. Whoops. Of course, I'll include a link to the graph in the description of the video. Also, A+JB on Discord later ported the real star map onto my graph, which was a really neat surprise. I'll also link their version below. And finally, a huge thank you to everyone that helped me make this graph and the video. It was really a fantastic journey and I can't wait to do more of this in the future. If you want to see more of my stuff, feel free to like and subscribe, because I got way cooler videos coming. Kill me! Kill me! Kill me! Kill me!
Like, subscribe, comment, and ring that notification bell because
I'm kidding.
I looked at my channel statistic and only 2% of you guys actually
I hate this! I hate it when they do this! But I have to.
You have to.
But it's like part of the...
Check out my Patreon too.
Oh my god.
Link in bio.
Wait. My dad's calling me. I need to tell him I'm filming something right now.